This is section 2, Algebraic Approach to Limits, example 4. So in this example, we're going to try to factor, okay? We'll see what happens. So let's look at it. The square root of x minus the square root of 5 over x minus 5. Is any of that factorable in a way that we're aware of? The answer is no. If I plug in 5, I get 5 minus 5 on the bottom, and the square root of 5 minus the square root of 5 on top, which is 0 over 0, which is indeterminate. Okay? Still a bad thing. So we're going to have to manipulate this somehow. And the way that we're going to do this, because of our roots, is going to be by multiplying by the conjugate. Okay, so hopefully you remember what that is. If not, this is what it is. The multiplying by the conjugate is taking both of the terms in the factor and doing the opposite sign in the middle. Okay, we're going to do that to the top and the bottom. So the square root of x plus root 5. And this is what we're going to end up simplifying. So we still have the limit as x approaches 5. Don't forget that. Now let's multiply the numerator out. Because when you multiply by the conjugate, you're going to end up eliminating the middle two terms, which is going to make this very nice to deal with. So the square root of x times the square root of x is just x. The square root of x times positive root 5 is positive root 5x. Negative root 5 times root x is negative root 5x. And negative root 5 times root 5 is negative 5. And then on the bottom, I'm not going to multiply those out. And you'll see why in a second. So if I cancel now, those go away. And we end up with the limit as x approaches 5 of x minus 5 over x minus 5 times root x plus root 5, which is very nice because that means that the x minus 5s will cancel. Okay, so because they cancel, we end up with the limit as x approaches 5 of 1 over the square root of x plus the square root of 5, and now we can just plug it in. So we end up with 1 over the square root of 5 plus the square root of 5. Now the reason we did all that is because the denominator was going to equal 0 and the numerator was going to equal 0. Well, now neither of them equal 0, right? It's not pretty, but it's just going to end up being 1 over 2 root 5. And I can do that because if I have 1 root 5 plus another root 5, I just have 2 of them. And that's the answer. In the past, you've been told that rationalizing the denominator is super, super important. You learned that in Algebra 2 and in Pre-Cal, and now I'm telling you that in Calculus it is not important at all. You don't have to do it. All right, just leave that as your answer. You can have a radical in the denominator. Right? It's not beneficial to anybody, practically speaking, for us to do that, to rationalize. So, sorry for all that wasted effort in the past. All right, let's do the same thing for part B. We're finding the limit as x approaches 9. 9 squared minus 81 is 0. The square root of 9 minus 3 is 0. So we're going to do the same thing. Okay, and we're going to remember, we're going to use the conjugate with the one that has the root because that's what's going to make it go away. So we're going to multiply by the square root of x plus 3 on the bottom and on the top. Okay, so the numerator, again, you don't have to multiply that out, right? We're just going to write it again because that's not the one that we use the conjugate for. It's the denominator that we're using conjugate for. So we have square root of x times the square root of x is x. The square root of x times 3 is 3 square roots of x. Negative 3 times root x is negative 3 root x. And negative 3 times positive 3 is negative 9. So those will cancel. And that's great. It's going to help us out a lot. So we end up with the limit as x approaches 9, x squared minus 81 times the square root of x plus 3 over x minus 9. Now you might notice, well, hey, I still have 9 minus 9 in the denominator and nothing canceled. However, x squared minus 81 factors. So let's go ahead and factor that. Remember, it's a difference of squares, so we get x plus 9 times x minus 9 times the square root of x plus 3 over x minus 9, so those cancel. Now we can plug in 9. I'm just going to go ahead and jump straight to that. 9 plus 9 is 18. The square root of 9 plus 3 is 6, and that's 108.